Okay, so this is day 2 of graphing functions using the first and the second derivative. Yesterday we did some easier problems. Today I'm going to do a rational function so that you can kind of see the difference. So we're going to, again, each equation we're going to find the asymptotes, do a first derivative test, a second derivative test, find our relative maximum minimums, inflection points, and then graph it. Okay? So this first one is a rational function. Okay, it's been divided, so to see it, we really need to make it easier on ourselves, get our common denominators, and create a rational function again. Okay, so we get common denominators, multiply the first one, top and the bottom by x, add them together, and that's what we get. So that'll allow us to get our asymptotes. Well, the bottom gives us our vertical asymptotes, so we have a vertical asymptote at x equals 0. Since the power on top is bigger, we have to do long division, and we find out that we have a slant asymptote, which is y equals x. Okay? So next we're going to find where it's increasing and decreasing. Well, to do that, we take the derivative, find the first derivative, but to do that, we do quotient rule. And when you're done and you simplify, you get x squared minus 9 over x squared. You set it equal to 0. Now, you have to find the zeros and where it's undefined. So my zeros are at plus or minus 3, and at x equals 0, it's undefined. Okay? So I have to use all three of those numbers on my first derivative test. So negative 3, 0 is undefined, that's a 0. Positive 3 is a 0. Okay, so now we go ahead and we test. So on this side, I plug in negative 4 into my first derivative, I get positive. Here I plug in negative 1, I get negative. Here I plug in positive 1, I get negative. Here I plug in 4, and I get positive. So this tells me where my function is increasing and decreasing. So at this 0, my function goes from increasing to decreasing. There is no 0 here, so we don't have a maximum or minimum. But at this 0, we go from decreasing to increasing, which means negative 3 is a maximum and positive 3 is a minimum. So this is relative max at negative 3 and relative min at 3. And we'll find those in just a minute. That also gives me my increasing and decreasing. So my increasing is here where it's positive, and here where it's positive. So less than negative 3 and greater than 3. So increasing from negative infinity to negative 3 and from 3 to infinity. Now it's decreasing in the middle there. It's decreasing from negative 3 to 0 and from 0 to 3. Now, you cannot say that it is decreasing at 0. That's why we cannot make this brackets, because it's undefined here. So we can't set it equal to 0. Same thing, negative 3 and 3. 0 doesn't have a positive or negative to it, so you can't include those. All right, so the next part is our concavity. So to find concavity, we need our second derivative. So again, we take the derivative of the derivative. Using quotient rule and simplifying, we get 18 over x cubed. Now, that means we don't have any zeros. We only have one point where it's undefined, and that's when x equals 0. So we set up our second derivative test. At 0, I'm undefined. Again, we test it just like we did the first derivative. So I plug in negative 1, I get negative, plug in positive 1, I get positive. So that tells me my concavity. So here it's concave down, or it cups down, and here my function is concave up, or it cups up. Now, so my concavity here is up from 0 to infinity because it's positive there, and down from negative infinity to 0. And since this is my only point, I have no point of inflection. Okay? I also, going back to my x-intercepts, since the numerator is never 0, I have no x-intercepts. And since the asymptote's on the y-axis, I have no y-intercepts. So the only thing I have left to do is plug in my 3 and negative 3 into my original function to find my maximum. And my maximum is at negative 3, negative 6. and my minimum is at 3, 6. Now, this goes to show you that if you don't do your derivative test, if you had just plugged in -3 and +3, and you had seen, oh, -3 it's -6, and at 3 it's 6, well then that means that -3, -6 should be my minimum because that number is less, right? And this is not the case in this case. So it's important to do that test, even though you think if you just plug in values and you see, oh, which one's lower, it doesn't always work that way. All right, so let's start graphing. Got all of our information. So we have a vertical asymptote here at 0. Then we have a slant asymptote. So we graph the line y equals x, which is this line right here. Okay. Then we have our relative max, which is at -3, -6, which is right there. And our minimum at 3, 6, which is right here. We have no points of inflection, no x-intercepts to graph. So let's see what we got. Well, we know that here at -3, it goes from increasing to decreasing. This is my maximum, okay? We also know that the concavity is concave down, so it opens down. So basically here, it comes up, hits that maximum point, and then comes down and follows the other asymptote. And the other one comes down here. This is my minimum value here, and has to go back up. And that is my graph. So again, especially those relative maxes and mins, if you had just gone back based on the numbers you saw, it would have given you a inaccurate picture. Okay, but we're just using all that information that we found to actually graph the rest of the function.